All right, so I'm going to do a screencast here, and I would like to clarify my thinking that I previously expressed confusion about in the week 4 screencast. So I have a whiteboard here, and was confused earlier about how indeed the forces on two charges that are near each other could be equal but opposite. Because my reasoning was that one charge, if they are not the same magnitude charge, one charge would be in an electric field that's larger than the other charge, and therefore the force is proportional to the electric field. So I thought the forces would not be reciprocal. But I failed to think and consider that not only are the electric fields differing in magnitude, the charges are differing in magnitude. And the equation here for the electric force taking the charge times the electric field that the charge is in will actually cause the forces to be equal but opposite. So, for example, even though you have 4 times the charge, it is in the electric field of the charge that is 4 times smaller. And that will work out to be the same product as multiplying a small charge times an electric field that is 4 times larger. And so I'm glad that I clarified that thinking. And I have one more thing I'd like to share. One, I'm just going to go ahead and share my work on the determining amount of charge on a piece of invisible tape. So this right here is the work that I've done. Here's the second page. It's probably is the most straightforward way of doing this. I found a little bit smaller charge on my tape than what the reading had suggested when they worked through this problem. And therefore, I also found fewer number of electrons spread out among the tape. But it still seemed to come out with a reasonable estimate based on the charge that I did have. Last thing I want to talk about is the additional experiments section of the reading. Those are great experiments, and I tried a few of them. But this one here, when I charged half of a piece of tape, the top half is charged. It's a little bit difficult to see, but the top half is charged. The bottom half is not charged. And against the white background, it's very difficult to see. But it seems like the condensation is gathering around the top half of the tape. And that would kind of make sense since the charged top half of the tape is attracting the polar water molecules in the atmosphere, more so than the uncharged bottom half of the tape. And the last part of that activity talks about taking a tape that's charged and blowing your breath on half of the tape. So here's the top half. Well, that definitely doesn't work. But anyway, it seemed the top half of the tape, there was condensation, but the bottom half, no condensation when I blew on it. So I'm not sure exactly what that shows us, but it's definitely worth thinking about.